Children, just to recap what we have studied till now in electrostatic. We have studied Coulomb's law of electrostatic. After that, electric field due to a point charge, electric field due to a system of charges, electric dipole, electric field due to dipole on its axial line and equatorial line. Now today we will discuss the electric dipole in electric field. And as we know, electric field may be uniform or non-uniform. So let us say it is the direction of electric field from left to right, and a small dipole is placed in the external field at angle theta. So see here, electric field is left to right and a dipole is placed in this field at an angle theta. Then the force on the plus q is along the direction of field, and on the minus q opposite to the direction of field. So net force on the dipole will be vector sum of force on the positive charge and the force on negative charge, and these two forces are equal but opposite, so net force is 0. And if net force is 0, then there's no translatory motion. Now here the field is uniform, so the magnitude of force is the same. But the line of action of these two forces are not same. One force is acting here, another force is here. So these two forces are equal and opposite, so they constitute a couple. And we know torque due to couple is either force into perpendicular distance between the force. So what will be the perpendicular distance? If we extend this line and draw the perpendicular from here, then this will be the perpendicular distance. And the value of this perpendicular distance will be, if we use here this angle is theta, so this perpendicular equal to 2a sine theta. So the magnitude of torque will be force into perpendicular distance, and that will be 2qa e sine theta. And remember, dipole moment P equal to q into 2a. So this quantity is dipole moment P e sine theta. In vector form we can write tau vector equal to vector P cross vector E. So here P is along the direction negative to positive, and electric field is left to right, so its direction will be perpendicular to the plane formed by P and E. So this, it is the perpendicular, means its direction will be perpendicular to the plane coming out. If this dipole is placed parallel to the electric field, that is at angle theta, then torque is 0, and as we discussed earlier, in the uniform electric field force net is 0. So the dipole is in complete equilibrium. This situation is called a stable equilibrium. If dipole is anti-parallel, means negative charge here this side, positive charge this side, so that dipole moment will be here right to left. This situation is called, though net force is 0, torque is 0, but this situation is called unstable equilibrium, because negative charge is here, so it will experience a force this side, and positive charge when will come here, it will experience a force left to right. Now if dipole is dipole is perpendicular to the electric field, that is theta equal to 90, then the torque is maximum. So this body, this torque will rotate, try to rotate, and momentarily it will come in equilibrium when it will align at angle 0. Now the dipole is non-uniform electric field. Two cases here we will take up. First, let electric field is increasing. Then here electric field is less, here electric field is more. So what will be the force on this plus charge and the force on this negative charge are not equal. So we can say F net is not equal to 0. If the field is decreasing, means here electric field is more, here electric field is less, then again force is not equal to 0. Hence a net force will act on the electric dipole. And as we discussed earlier, the torque is always there. So only in non-uniform external field, the dipole will experience a force, while in uniform electric field, net force is 0. Now, a very simple question here given. First, show diagrammatically the orientation of an electric dipole placed in uniform field with its dipole moment parallel to the field, perpendicular to the field, anti-parallel to the field. Find the net force and torque in each case. And second question, an electric dipole consists of 2-point charges of magnitude 4 into 10 to the power minus 8 coulomb lying in uniform electric field 10 to the power 4 Newton per coulomb. Find dipole moment and number 2 torque acting on the dipole. In our syllabus, mainly non-uniform electric field is not in our syllabus, only uniform electric field. So the most of the question will be related to the uniform electric field. Here we can create a question from the first part of the chapter, that frictional electricity. When we rub a comb over our dry hair, it attracts a piece of paper. Why it attracts? The paper is not charged, but the comb is electrically charged due to friction. So when the charged comb brought near to the paper, it attracts because electric field, it polarizes the charge over the paper. So a net dipole moment established, and due to this polarization it attracts the charge.